Okay, we're here. Let's have another example. Okay, I will not change the example. Are you hearing me? I need to make sure. Do you hear me? Can anyone respond to me? Can you hear me?
Yes, teacher.
Evet hocam.
Okay, very well, thank you. Okay, I'll have another example. In fact, I don't want to write another example. I'll use the same example. I'll change the hypothesis. Use the data presented in the previous example to test the following hypothesis. And construct a 95% confidence interval for mean GPS. Okay, the hypothesis this time I'm constructing something else. Mu is, the claim is mu is less than 3.0 and the null hypothesis is going to be mu is greater than 3.0. Okay, let's get directly to the solution. Okay, so we need to write down whatever we have. Let me, okay, write it myself. X bar, the X bar equals 2.8194. And the sample standard deviation was 0.6159. And the sample size is 36. And mu null is changing now. It's 3.03. Okay, what else do I need? So I need to okay, use the data presented in the previous example to test the following hypothesis, which I have forgotten to write here. I'm going to move on this bit. With alpha equals 4.05 level of signature level. Okay, so it's easy. So alpha is given 0.05, the critical value. So it's left-sided. This one is left-sided, critical. Let me take it down here, the critical value. Yeah, right here equals minus, since it's left-sided, I will have it on the left side, Z1 minus alpha, or equal Z alpha. And that is either you can look at Z 0.05 from the first table I presented you, or this is equal to minus Z 0.95. Either one is okay. So I'll go straight to the Gaussian distribution table. I need to look for where 0.05 is located. So 0.05 is here. Look at that. 0.505 I have, which is greater than 0.05. And this is less than 0.05. So it's between minus 1.6 and between this one and this one. So the result is easily calculated. So it's going to be, this is minus 1.64 between and minus 1.65. So in the mid, so the result is minus 1.645. 645. So the calculated statistics, remember, the calculated statistics equals the x bar minus mu null and divided by the sample standard deviation, and this is also divided by the square root of the sample size n. Okay, let's see what we have. 2.8194 minus 3.0 or 3, and the sample standard deviation is 0.6159 divided by the square root of 36, and the result I can use Excel, and here I'll modify. I will not subtract 2.6, I'm going to subtract 3. Okay, the result is minus 1.7594. Okay, that's the result of the calculated statistics, and we know the critical value. So I'm going to place a graph, the graphical display of the Gaussian distribution on the following page. Yeah, there it is. So this is a left-sided look. You will understand from the alternative hypothesis. So if it's less, it's left-sided. So I'm placing the critical region on the left. Okay, so let's think that this is okay. All right, this is the left region, reject region. Let's reject. This is 0.05, and this is minus 1.645, the critical value. So let me just highlight this bit here. Highlight it. Okay. Right there. There it is. Okay, the calculated statistics is minus 1.75, which is less than the critical value. So it's simply falling within the reject region. So I'll try to have this in color red. Yeah, there it is. So I'll place it here, right here. So this is minus 1.7594. Okay, simply falling within the rejection region. Okay, since minus 1.7594 is less than minus 1.645 or minus 1.7594 is falling within the reject area. The null hypothesis is rejected. With alpha 0.05 level of significance. It means there is evidence to say that the mean GPAs is less than 3 with 0.05 level of significance. Okay, that's the interpretation we can make after testing the hypothesis. So it's easy now to construct a 95% confidence interval for the mean population, mean GPAs. The confidence interval and 95% confidence interval for mean GPAs is as follows. Okay, remember the confidence interval was X bar minus Z1 minus alpha divided by 2 times S, the sample standard deviation, divided by the square root of the sample size, less equal mu, less equal X bar plus Z1 minus alpha divided by 2 times S divided by the square root of N. Okay, we also need the critical value Z1 minus 0.05 divided by 2. This is Z 0.975. So it's easy to determine this from the second Gaussian distribution table. Look, table E. We need to look for the value of 0.975. So there it is. You see, it's already there. So it's 1.9 and 1.06. So the result is 1.96 for that value. 1.96. So I can easily write the result as 1.96. Okay. All right. So I can Now I can perform the lower bound, the calculation for the lower bound and the upper bound. We know the sample mean is 2.84, 8194 minus 1.96 times the sample standard deviation was 4.6159, and that's divided by the square root of 36. This is loss equal mu is equal 2.8194 plus 1.96 times 4.6159 divided by the square root of 36. Okay, I'll use a calculator, scientific calculator, to get the results. For the lower bound, 2.8194 minus 1.96 times 6159. So the lower bound, I find out 2.6182 less equal mu is equal this is the upper bound, 3.0206. Okay. Okay, to interpret the confidence interval, we can tell that the mean GPAs is between 2.6182 and 3.0206 with 95% confidence level. Or with a confidence with 95% of confidence, we are confident 95% confidence to tell that the mean GPA is between 2.6182 and 3.0206. Let me write the interpretation of the confidence interval. We are confident 95% to say that the mean GPA is between 2.6182 and 3.0206. That's the interpretation. Okay. I hope you're clarified about testing and building a confidence interval for a certain confidence level. Got it? You there following? Okay, perhaps you're not in front of the screen. All right, the next thing is the next subject, C. Hyperos testing and confidence interval for mean population. sigma is unknown and n is less than 30. What happens if n is less than 30? So there is another thing, and n is less than 30. The calculation is exactly the same as for n is greater than 30. The only difference is we're not using the same critical value. We're using this time the t distribution. The critical value will be obtained from the t distribution. So I'm gonna copy the same things there, right there, here. Okay, I'm gonna copy all this stuff here. Okay. Place it here. Yeah, there it is. I don't need this, delete it. Okay. So I'll modify everything here because the same hypothesis we construct, no difference, left-sided, right-sided, and double-sided. We construct such hypothesis, the same hypothesis. And this time we're not using the Z calculated statistics. The name is changing. I will change it as T calculated. This is T. The name is changing. The way of the calculation is no different. So I'll have to modify this stuff, this place here as well. This is not Z anymore. Yeah, everything I will modify everything here I have. Yeah, of course, I'm not using this here. I'll delete all the stuff here. I'll delete all the stuff here. Okay, this is also T. This is T also. Okay, modify this. This is T and minus 1 alpha divided by 2 T and minus 1 alpha divided by 2 times S divided by the square root of n. Okay, let's get back here. Need to move this stuff here. This, yeah. Okay. Okay, when the constructed hypothesis is given as left tail, if the calculated statistics T is less than T, it's minus, of course, this is negative, T n minus 1 alpha divided by 2. Then the null hypothesis is rejected with alpha Laplace significance. And the T calculated statistics is greater than T n minus 1 alpha divided by 2. Then it's the null hypothesis is rejected. And the absolute value of the calculated statistics is greater than T n minus 1 alpha divided by 2, then the null hypothesis is rejected. Okay, let me show you how we bring the critical value for T from the T distribution. It's much easier than the standard normal distribution. Let me show you. Okay. Suppose the alpha level is 0.05. I'm so sorry, I need to pick up this phone call. Let me just Okay, I'm back. Sorry for the interruption. Okay, so if alpha is 0.05 from T distribution and the sample size is, say, 23, so the critical value for T n minus 1 alpha, that is going to be T 22. 22 is degree of freedom. This is degree of freedom. That's degree of freedom, you call it. You call this one is degree of freedom. Okay. So in this case, if the sample size is 23, the degree of freedom will be 23 minus 1. So the result is 22. So if I'm using the same alpha level, is if this is the one-tailed distribution, so the alpha, I'll use the alpha itself, 0.05. The result of this one, I need to bring it with a certain different table. It's called table F, the T distribution table. I will supply you within the lecture note today. You will have it today. Okay, look. See, this is the degree of freedom. So we need to look for 22 and 0.051 tail 0.05. So 22, 0.05, this is 1.717. It's easily determined. It's not hard really. So I can easily write the output for this critical value, which is 1.717. Okay. So what about if I write you something else? If I tell you to tell me what the value of this one, look, 17 0.01. Can you tell me the result for this one? Let me copy this. So if I get to the table, the T distribution table, I'm asking you to determine this value. What is the result of this? Okay. Can you tell what the value of this one? From the table easily. Read the table and tell me the result of T17 0.01. So I need to look for, from the degree of freedom, 17 easily. Okay, so I need to look for the result, the critical value within this row. Okay, 0.01, I need to find out where 0.01 is located on the columns. So this column, I'm interested in this column and in this row. So I will intersect here. So the result is 2.567. So the result is 2.567. So I will rewrite here also 2.567. Okay. So we had two examples to determine the critical value from the T distribution. I can now get straight to an example how to test the hypothesis using the T distribution, the critical T distribution table. Let me write an example. I have 10 minutes to go. I will write the example and have a break for 10 minutes. Okay. Example. Okay. The students who are measuring at Atılım University is spending in average 200 Turkish liras a day. To test such statement, spending less than, let's say spending less in average. I will change the sentence. Okay, rewrite back. Spending less than 200 Turkish liras a day to test such statement is true or not. Um, 16 students are randomly selected from those who are measuring at Atılım University. The result of spending are given as follows. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. Okay. I've done this example, similar one, the third section today, and the result, I have written the result here, and I'd like to use the same output. The first person is spending 255, 215. The second person is 192. The third one is 175. And the next one is 255, 144, 177, 205, 290, 110, 120, and 300, 105, 155, 190, 195, and 145. Okay, that's the, okay, let's complete the question. Use alpha 0.05 level of significance to test that whether the student of Atılım are spending less than 200 Turkish liras a day in average. Construct a 95% confidence interval for me spending. Okay, so I think I won't be able to complete the solution of this exercise. All right, I'll try to begin the solution. The remaining time, what is the remaining? Does it tell anything about the remaining? It's less than 2 minutes. It's around 1 minute. So I'll write whatever I have. I'll construct the null hypothesis. The null may, and the alternative is the statement, the judgment, may less than 200. And the null hypothesis is going to be mu is greater than 200. And the alpha level is given 0.05. It's less than a minute. I will end up the session. I'll be back in 10 minutes of time. So I shall see you just in 10 minutes of time. Okay. Although I stopped sharing and I was speaking myself. Anyway. Okay, I will end up the session.